This is Cameron Chai from Azom.com, and I'm speaking to Mike Fogarty from Rheotek, and he's going to take us through their automatic kinematic viscometer.
Yes, the ASTM method for doing jet fuels, this particular system was developed to automate fuels in general, but jet fuel testing, the viscosity, kinematic viscosity of jet fuels. There's an ASTM method, ASTM D445, and it's a requirement of the method that we fully comply with the ASTM method. Basically, we're automating this glass capillary viscometer. This is an ASTM U-balota viscometer that's used to measure the fluid. The sample, the viscometer, would be mounted in a temperature-controlled bath. This bath is unique because it's capable of reaching temperatures, subambient temperatures, down to -20 or -40 degrees C. There's a requirement for jet fuels to automate the viscosity testing for jet fuels. This same system, this same bath, can be automatically ramped up to +40 degrees C and run applications like diesel fuels. And there are specifications for viscosity in diesel fuels. The operation of the system is we think, quite unique. We've developed what we call a filling station. The sample is syringed in to the filling station. At this point, the sample would fall into the glass capillary viscometer. The temperature bath would automatically ramp. It'll pull the sample up, dry the viscometer, drop it to -20, let it stabilize. We have developed some excellent technology for temperature control. We can control the temperature of the test at -20 to ±0.01 degrees C. The test is then measured twice. So basically, we're pulling the sample up the capillary and releasing it, and we're timing a fixed volume out to 100th of a second. And then we calculate the kinematic viscosity. The system can print a report for an operator. It can also, it has a LIMS port. It can automatically send data out through the LIMS port. The data is quite exceptional. Our determinability on this test is typically we're going to be better than 0.2%. Frequently, we're going to be inside of 0.1%. In this case, these are a series of round-robin samples we've run, and the determinability, the average here is 0.01 degrees or percent. So that's it's quite good. The system also has a lot of intelligence that we've built in. It's important because of different climate conditions, environmental conditions from lab to lab. We measure the temperature of the lab. We measure the relative humidity. We know exactly what the dew point is in the particular lab that the system would live in. It automatically brings the system to 2 degrees above dew point to clean the sample and then report it, and then we're ready to go again.
All right, Mike, and it's also suited to doing batch testing, is it? Like I see you've got the computer, the USB ports there for downloading all your information after having done a series of runs?
Yes, that's correct. The actual computer is on board. We have also developed some black box technology in this system, so if you frequently or maybe infrequently, hopefully, computers do crash, hence the JETVISC and the black box technology. We save all of the relevant information. We can simply using a engineering stick or a supervisor stick, we can reprogram the system, or we could, if we needed to, we could replace the computer install the stick, it automatically reprograms the system. The operator doesn't have to do anything.
Right.
The system has also been designed for easy access to any component. The system will actually pull apart. All of the panels on the system are removable. We have access to every area of the viscometer, left, right, rear, and of course inside. What's important too is when you're running these types of tests, there's a requirement that the viscometer must be calibrated in an ISO 17025 accredited lab. Our lab is. We actually produce a full series of certified viscosity standards for calibrating the viscometers.
Right, and what materials is this suited to testing? Jet fuels and other types of?
Jet fuel, any type of fuels. And they're typically going to be, jet fuels are typically done at minus 20. We can do hydraulics. We can do transformer oils. There's a whole array of applications at sub-ambient temperature that we're capable of automating. And then when you get into some of the diesel fuels, the test specification is at plus 40 degrees C, plus or minus 0.02 is what the method calls for, and we can automate those. We can actually, with a second module, the bath and viscometer module, we could actually have two tests going. We could have a diesel running at plus 40. We could have a jet fuel or a hydraulic running at sub-ambient simultaneously and independently of each other.
All right, Mike, thanks for telling us about your kinematic viscometer.
Thank you.